Hello all, welcome to this short crash course on MCP. MCP is nothing but it's a model context protocol. So in this specific video we will going to learn in detail about about model context protocol, why it is introduced, what is the use of it, where it fits in. Already we have this RAG models, right, AI agentic framework. So how it solves the problems which are in the existing architecture, where it fits. So all those details we are going to see in the subsequent slides, and later we will see a live demo. Maybe in another video you can see that how to create these MCP servers, and how your MCP clients uses this model context protocol to connect to a server, and how it provides information to the LLM models. So those things basically we are going to see in the subsequent slides and in subsequent videos as well. So let me, before going into much detail of this MCP, I will just probably jump into the how without MCP current scenarios are there. Okay, so let me directly move to that slide. So here you can see before MCP. Now see your application, this LLM based application which you have created. It has some agents or a source code which you have written which uses this LLM models, right? It can be Llama, or it can be Mistral, or it can be anything. So what it does, right? It understood your right client's intent. Like suppose client has asked what's the weather in the New York. Now LLM models, right? These are pre-trained, right, models. They don't have the real-time data. So in these scenarios, agents will come in picture. So LLM will contact some agents which will provide this informations, and agent in turns, basically your agent code in turns communicates with a certain tools, or it makes an API call, and that tools or an API in turn returns you with the real time weather information, and then your agent consumes it and it supplied back to the LLM, and LLM does all those massaging and all those things on this response and sends back to the client. So as you can see right here, weather API URL and headers, it needs some token as well to call this API. So agent need all these informations before sending any request to get these informations, and also this payload is also predefined, as you can see. Now just think about this. If you have so many agents, now you have to handle all those agents. You have to write code for all the agents here, and it is communicating to the tools with different APIs, or different mechanisms are there to get the details or to get that fetch the data and providing back to the LLM. So those things should be managed by this agent itself. If there is, suppose in future, if there is a change in the API payload request body or something, or maybe now whether API is changed, some response it is giving in a different format, or some new fields are introduced, so in that case agent has to manage this, and agent will break basically that time. Then agent has to change it, their code. So this is the basically drawback I can say, or this is the current scenario how our agentics frameworks are being used here. So let's jump to our main topic about MCP. So MCP context protocol, right? What it's an open standard framework introduced by Anthropic, basically to standardize the way of AI models like LLMs integrate and share the data with external tools, systems, and data sources. So MCP is what? MCP is an open source protocol that standardizes how applications provide context to LLMs. So in simple words, you can understand like this. Think that MCP is just like a USB-C port for an AI application. Just as USB-C provides a standardized way to connect to your devices, to your various peripherals and accessories, MCP provides a standardized way to connect AI models to different data sources and tools. MCP helps you bring agents and complex workflow on top of LLM. LLMs frequently need to integrate with data and tools, and MCP provides a growing list of pre-built integrations that your LLM can directly plug into. The flexibility to switch between LLM providers and vendors, and best practices for securing your data within your infrastructure. So these are the major things which MCP provides, and that's why it is quite being popular today in agentic AI frameworks to introduce this MCP protocol. Let's move to next slide. So this is just high level MCP architecture, you can see. So it is built on a flexible, extensible architecture that enables a seamless communication between your LLM applications and integrations. Now see, it is a very simple architecture. It's based on the client server architecture, where there is a host, there is a client and server. So hosts are basically what? Your LLM applications. Suppose in your laptop, if you are doing right, it can be your IDE. If you are using a cursor AI IDE, it can be your cursor AI is your host. Cloud desktop, if you are using, so cloud desktop will be your host. Basically that client that initiates the connections. Now after that, there is a client which maintains 1:1 connection with the server inside the host application. So in your host application, right, there is a client, like in my IDE or my cloud desktop, there is a client which maintains 1:1 connection with the server, MCP server, inside the host application. Now servers are what? Servers basically provides the context, tools and prompts to the clients. So in this diagram, you can see host is MCP client, and in between there is a transport layer, and then your server, MCP server. There are n number of MCP servers which is communicating through this transport layer using this MCP protocol. So as you can see, this transport layer handles the actual communication between your client and servers. MCP supports multiple transport mechanism. So one is STD-IO transport. Basically STD-IO transport uses your standard input output for communications. This is ideal for your local processes mainly. And it also have a server sent events. HTTP with SSE transport basically. So it server sent events for server to client messages basically. Now it is suitable for these HTTP posts for a client to server messages. And please note, all transports use this JSON RPC 2.0 to exchange the messages in between. So it uses JSON to come for its communications, exchange messages. Now for your best practices, see, it is advisable to use this for local communications mainly. You should use STD-IO transport, and because it is very efficient for same machine communication. If in the same machine, if your server is there and client is there, then it is very efficient for a same machine communications. And simple process management it provides. It's just say you have your one Python file which is acting as a server in your machine, and which in turn it's connect to the actual data server. Now remote communications mainly, you need to go with SSE obviously, because it needs HTTP compatibility, and consider security it mainly considers all those security implications also, like authentication and authorizations you need to take care in this when you are going with the remote communication. So these are like high level best practices and transport layer details what MCP provides. So this we have already seen before. MCP it's look like this.